You might have heard people say things like, keep it simple or don't overthink it. But in our hyper-complex world where problems have multiple solutions and thousands of variables, how do we know when we've found the simplest solution to a problem? How can we be sure that we're not overthinking something that isn't actually worth our time and energy? And how can we cut through all of the noise and get to the heart of any matter quickly and efficiently? Well, over 700 years ago, a 14th century Italian philosopher and scientist named William of Occam provided us with a tool that helps us think more clearly and solve problems more efficiently. In this episode, we're going to explore Occam's razor, the powerful idea that can help you become a sharper thinker. So let's get started. As we just mentioned, Occam's razor was first introduced by 14th century Italian philosopher William of Occam. Now, William wasn't thinking about how his idea could change the way we think about business problems or help scientists develop new theories. Instead, he was trying to explain how we can better understand God. As he saw it, many philosophers had taken a simple concept, God, and made him unnecessarily complex. They were adding extra baggage to an idea that didn't need it. So he came up with the idea of Occam's razor to cut away all the unnecessary complexity. This razor is based on the Latin phrase, entia non multiplicanda sunt, which translates to, entities should not be multiplied beyond necessity. It just means that when we're trying to explain or understand something, we shouldn't make it more complicated than it needs to be. Let's take a look at some examples of what Occam's razor looks like in action. Let's say you're trying to explain why your car won't start. One possible explanation is that the battery is dead. Another explanation is that there's a problem with the starter motor. Which of these explanations is simpler? Well, the answer depends on the knowledge that you bring to the situation. If you know that cars typically don't start if the battery is dead, then the first explanation is simpler because it requires less information to understand. However, if you're not particularly knowledgeable about cars, then the second explanation is simpler because you'll need to learn less overall to understand it. In this example, Occam's razor tells us to choose the explanation that requires the least amount of information. But what if both explanations require the same amount of information? In this case, we should choose the explanation that's more consistent with our existing knowledge or beliefs. For example, let's say you're trying to explain a new software bug, and there are two equally likely explanations. If one explanation is more consistent with the code that you wrote, then you should choose that explanation, even if it's not technically simpler. But it's not just useful for figuring out what to believe. It can also be used to evaluate different ways of doing things. When faced with two different methods of accomplishing a task, the one that requires fewer assumptions and less information is usually the better choice. For example, if you're trying to decide between two different software development methodologies, all other things being equal, the simpler approach is likely to be the more effective one. Same goes for choosing between different investment strategies or political systems. All else being equal, the simpler approach is usually the better one. One great thing about Occam's razor is that it's easy to understand and apply in most cases. But its simplicity is also its biggest weakness. Like any simple rule, it's sometimes better to break it than to follow it blindly. Occam's razor isn't always right. Sometimes the more complex explanation is actually the correct one. For example, in the late 1800s, scientists were trying to explain how the planets in the solar system move around the sun. Newtonian physics couldn't explain the observed motion of planets without introducing a lot of ad hoc assumptions. This led to the development of Einstein's theory of general relativity, which was more complex than Newtonian physics, but was able to explain the same phenomena with fewer assumptions. Another issue with Occam's razor is that it can be difficult to determine which explanation requires less information. Sometimes this is obvious, like when one explanation requires you to believe in a talking unicorn. But in many cases, it's not so clear. For example, if you see a bird that can't fly, you might wonder if it's a penguin. Is the explanation, this is a penguin, simpler than this is a bird that can't fly? It depends on what you already know. If you're from the northern hemisphere, then the first explanation is simpler because you know that there are places on Earth where it's cold enough for penguins to live. On the other hand, if you're from the southern hemisphere, then the second explanation is simpler because you know that birds that can't fly are rare, while penguins are common. So as you can see, Occam's razor is a useful but imperfect tool. It should be used with caution and should never be applied blindly. But that doesn't mean that it's not a valuable tool. In fact, it's probably one of the most important tools that we have for understanding complex systems and making decisions in the face of uncertainty. Here are 3 takeaways that we hope will help you put Occam's razor to good use. First, Occam's razor is a guideline for decision-making in situations where there are multiple possible explanations for what we observe. It tells us to choose the explanation that requires the least amount of information or assumptions. Second, Occam's razor is a tool for evaluating different ways of doing things. When faced with 2 different methods of accomplishing a task, all other things being equal, the simpler approach is usually the better one. Third, Occam's razor is not a law of nature. It's just a useful guideline. We should use it with caution and should never apply it blindly. If you enjoyed this episode, we think you'll love the episode on the scientific method. We explore how the scientific method works and how it helps us to understand the world around us. We also discuss some of the limitations of the scientific method and how it can be used and abused. And that's all for this episode. Thank you for watching and listening, and if you liked it, please leave us a review. Your feedback helps us make better videos and reach more learners like you. And if you really want to dive deeper into the science behind everyday life, subscribe to our channel. Thanks again for watching, and we'll see you next time.